All right, hey guys. All right, so we are starting our exponential functions lessons. Okay, so this is just our lesson over pretty much introducing them. So there's three main things that we're going to talk about today. Which is, the first thing is the two types of exponential functions. So our two types are exponential growth and exponential decay. Okay, this first graph right here shows us exponential growth. So exponential growth is going to increase from left to right. Remember, we always go from left to right. Okay, so as I'm starting at the left, notice it is going up. No matter which way I go. If I go to the right, it's still an increase. If I go up, it's still an increase. So it increases from left to right. Okay. Our exponential decay is the graph on the right. Notice as it goes from left to right, it drops down. Okay, so it decreases from left to right. So make sure you know what each one of them looks like, because you may be tested over just knowing what they look like. Okay, the next thing we're going to talk about is something that you should already know, which is the point where our graph crosses or touches our y-axis, which we should all know to be the y-intercept. Okay, and at the y-intercept, our x value is always 0. X value is 0. So as I look at this graph, here's my y-axis. I like that one too. The graph crosses the y-axis right here. So this is my y-intercept. This number is 1. So my y-intercept has a value of 1. And we write that ordered pair as 0, 1. So remember, our x value is always 0, and the y value is the 1. So on the graph on the right, the graph crosses right here. That number is a -3. So the value of our y-intercept is -3, and we would write the ordered pair as 0, -3. Okay, that's the y-intercept. Okay, the last thing we're going to talk about in today's video is something new called the asymptote. Asymptote. Okay, your asymptote is this line right here that's dashed. So it's basically an invisible straight line that your graph is going to get very close to, but it's not going to touch it. It may look like it touches it, but it's not. Okay? And our asymptote is always written as an equation. Okay? You can't just say my asymptote is 5 or my asymptote is -2. Okay? It has to say y equals 5, y equals -2. Okay? So we notice we have a horizontal line that our asymptote is. Remember, horizontal lines have equations that say y equals, because it's going to go through your y-axis at a value right here. So in this case, our asymptote is y equals 0. Okay? Because it's going through our y-axis here. Y-axis. And it goes through it right there at the 0. Okay, and this graph on the right, dashed line is our asymptote. Notice it gets really close to it, but it never touches it. And the number on that line is the -2. So therefore, our asymptote is y equals -2. Okay, so that's all we have to do for an asymptote, is write the equation of that line that it gets close to but never touches. All right, so now got some u-dos. All right, so you may see some statements on the graph. The first thing I need you to do is make sure you do your part. So you come over here and you write all the information you know about this graph. So it's going down from left to right, so we should know this is decay. We're going to label this as decay. Okay, then we're going to find our y-intercept and label it. Okay, and then we're going to determine where's our asymptote. So it's getting close to this line right here, which is the x-axis. So if the asymptote is the x-axis, that means the equation of the asymptote is y equals 0. Now we're going to come back over here and find the one that matches our information. Okay, it says determine whether each statement is true or false. So the y-intercept is 1, 0. That's not what I wrote right there, is it? So no, that's false. Y-intercept is 0, 1. Yeah, that's what I wrote. Let's check. That's true. Okay, graph represents exponential growth. No, I wrote that it's decay. So that's false. That's true. It's decay. Okay, asymptote is x equals 0. No, our asymptote is a horizontal line, so it's definitely got to say y equals. So that's false. Asymptote y equals 0. That's true. Okay, so all you got to do is look over there and see what we already wrote. All right, calculator. The steps are right here. Just do exactly what it says. Okay? So I'm going to do this one last one, and really you're not going to be able to see what I'm doing in the calculator. So if you put this in the calculator as it says, we graph as we normally do. Okay? So you're going to go to your graphs. Okay? Type in what is after your equal sign. So you're 73, hit your parentheses, control divide, 4 over 5, go out of your parentheses. Now, to put this exponent of an x, because it must be an exponent, you're going to hit that little caret symbol, and I think it's right under the equal sign. And then you'll put the x. And it'll raise it up like an exponent. Okay, so that's how you enter any exponent. Use that little symbol under the equal sign, and then put in whatever your exponent is. Okay, and then you'll hit enter. Okay, once you hit enter, it should graph it. If when you hit enter you don't see the graph because your window is out of range, then if you hit menu 4A, I believe it is, menu 4A, it should zoom in on it so that you can see the graph. Okay? Now once you do that, you're going to do Control T. Okay, no arrow. It's just Control and then T. And it'll bring up your table where you can see some values. Okay? Once you do that, all you got to do is hit your up arrow one time and you'll see your y-intercept. So after you do that in your calculator, it's going to tell you that your y-intercept for this graph is 0.73. Therefore, your y-intercept has a value of 73. Okay? And if you're paying attention, you'll notice right here, that's the same number. That is your y-intercept. That's pretty much all you need to know in today's lesson. You should be able to go on and finish up everything from here on out. Because even all the other I do's and you do's, it's pretty much the same thing. It's just calculator stuff. All right. That's graphing exponential functions.